Hello learners, welcome to GreatStack, the Pro Python course. This Python course is designed to provide a solid foundation for beginners. Python is known for its simplicity and readability. It is a very versatile language used in various domains such as web development, data analysis, or artificial intelligence. This course begins with the introduction of basic principles of programming such as variables, data types, control structures, and functions. You will learn how to write your first Python code and gradually progress to more complex topics like loops and error handling. You will gain a comprehensive understanding of object-oriented programming, including classes, objects, inheritance, which are essential for building robust and scalable applications. So, what is Python? Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Dynamic semantics means that the meaning of the sentences are not proportions, but rather there are functions that alter the context we wrote in the code. It has a multi-platform support. Its syntax is simple and similar to English language. It can be treated in a procedural way, an object-oriented way, or a functional way. So where can we use Python? Python can be used to create server for web applications using frameworks like Django or Flask. It can be used to create workflows. It can be also used to read and modify files saved on database system, whether they are relational or non-relational. It can be used to handle big data, and it is also used in machine learning, deep learning, image annotation, and there are much more things to do with Python. Let's move to the syllabus discussion. This course will start with the introduction to Python. Then I will show you what are the basic installations that we need to do before starting with Python. And then we'll understand what exactly happens behind the IDM. Then we'll be covering simple topics like variables, learning about how to take input, what are data types, string methods, what are type conversion, comments, arithmetic operations, operator precedence, math function. Then we'll move to conditional statements, logical operators, comparison operators, loops, where we'll also learning about the for loops, while loops, and nested loopings. Then we'll move to lists, where we'll learn about 2D list methods, range, set, tuples, and how to unpack lists. Then we'll be moving to dictionaries, and where we'll be learning about what are dictionaries and how to unpack these dictionaries, the different ways of unpacking dictionaries. Then we'll be learning about functions which will make your journey, the coding journey, easier. And then we'll moving to exception handling, which will take you to the road of a better coder. And then in addition, you'll be also getting a lot of exercises which will help you to get your hands on some real Python. So now it's time to step into the world of programming, and welcome to GreatStack. Now let's move forward to the Python installation. For this, go to your browser and search for download Python. The first link you will get is python.org. Go to the website and download the latest version of Python. Once the download is complete, click on the app and click on this checkbox python.exe to path if you are using Windows, and if you are using Mac, you don't need to do this. Then click on customize installation. Next, and here click on install Python 3.11 for all users. Then click on install. Once the download is complete, go to your command prompt and type python --version. Here you will see the version of your Python. If you are not getting this, there is an issue in your installation, you have to reinstall it. Once you are done the setup of Python, you can use Python in your terminal to write codes and execute. However, using a code editor makes everything a lot easier and convenient. The code editor we will be using is PyCharm. PyCharm is a popular integrated development environment that is IDE specially designed for Python programming. It offers a wide range of features and tools that enhance the development process and improve productivity. Also, it provides intelligent code completion, syntax highlighting, debugging capabilities, and built-in version control integration. It also supports web development frameworks like Django and Flask. So, to get started with PyCharm, you need to go to your browser and search download PyCharm. The first link you will get is jetbrains.com. Go to the website and download the community version. The professional version is not free, however it's free for 30 days, but you can prefer the community version. It's free. Once the download is complete, you can open the app and you just need to install it. Click on next, click on these checkboxes, admin folder, and now you just need to click install and your installation will be completed. Once you are done with the setup, you will get the option to reboot. So either you can reboot later or reboot now. I'll click reboot now and join you after the reboot is completed. Once the reboot is completed, search for PyCharm Community Edition and then you will be on this app. Add new project. You can set the location by yourself. I will make it default and create. Now you are here in this Python main.py. Now you can start your coding journey. So before diving into the real coding, let's know what happens behind the IDE or what happens behind the PyCharm. As we know, Python is both an interpreted and compiled language, but calling it a compiled language is a little different here. It is not compiled to a machine language. It is translated into an intermediate code which is called the bytecode. This bytecode needs to be executed in the Python virtual machine or the PVM. However, you don't need to bother in the execution of your program as it is very well automated. But the automation may consume more time, which is however negligible if you consider the reduction of efforts and the amount of facilities that is provided by Python. And this is the reason why Python is most loved language all over the globe. If you are planning to go further with Python in machine learning, data analytics, it would easily reduce your efforts with a huge margin. That is, you can literally write a 200 lines of Java code in 20 lines of Python in a better and readable format. It is that powerful. Now starting with variables in Python. So what are variables? Variables are just the same thing that you have studied in your maths of your academics. Basically, these are the elements that can change or vary. Or in more technical terms, these are the representation of a value that you declared for them, like stored on a memory space. So these are used to store data. So for example, we can take a value like a variable x which will store the value 5, which is an integer value. So it can store the value 5 or it like x store 5, or if we want to print x. So let's see 5 is printed. So this is how this value 5 was stored in this variable x, or it can also store your name. So for example, GreatStack can be stored in X. So here X is the representation of the value GreatStack. So let's run this and see. See, GreatStack is printed. So these are variables. Now we'll learn about how to take input for a variable. Like how can you take a user input? So for this, what you need to do is you have to store whatever you will take from the user in something. So what is that something? It's a variable. So basically we have to store whatever we want to take from the user to a variable. So it is this simple. We just write to this input, and inside the prompt we just write whatever we need to write, like enter anything. So this is how this function, this general function, will take input from the user or from you, and this input, whatever this input the user will provide, this will be stored in X. And now we can just print X. So if we run this, enter anything. So let's try to write like enter 6. Enter, 6 was printed. Yes, 6 was stored in this X and 6 was printed then. But if you see what is the type of this X, like this X that I took from the user, what is the type of X? However, I entered as input, that is an integer, but is it stored as an integer? Let's see. 6, enter. It is stored as a string. So whatever input you are taking, it will be stored as a string. So for this, to convert it from string to integer, for any operations like arithmetic operations or math operations, whatever you will do for your program, you just need to write it in bracket and write like this int. So now this will basically type convert this string into an integer. So the input will be taken as a string 6, and this 6 like this 6 will be converted into an integer. So this is how it will work, and now X will be an integer. So let's run this and see it's an integer. So you will learn more about type conversion in our next topic, and this is how you should take a user input and use it in your program. Now, as you are fully packed up to dive into the world of coding, let's start with your first Python program. Here I will show you how to display a statement. For this, write print followed by parenthesis, and in this parenthesis you have to specify what will be your statement. So our first statement will be hello world. You need to click on this run button, and here our hello world is printed. You can also write multiple statements concatenated by a plus symbol. For example, print hello is a statement concatenation with world. So here, after running, you can see it's printed hello world. However, this plus symbol or the concatenation symbol is not mandatory. Like your program will work without these two. But this is not the standard practice. Following a standard practice is very important for writing a quality code, as it is very preferred in software development. You can also write multiple statements in this print. So like I am writing print and following it with hello, and if you wish to print your statement in multiple lines, you need to add 3 apostrophes like this, and here it will be a multi-line statement. So here is your multi-line statement. If I run it, you can see the hello and world are printed separately, hello, and in next line it's printed world or hi there. See, this is how you should write a multi-line statement. So now you are done with your first Python program, data types in Python. Data types are a particular kind of data item defined by its value it can take or operations that can be performed on it. So, what are different types of data types? There are numeric data types containing integer, float, or complex. Let me show you. A equals 5. As 5 is an integer, so A is an integer type data type. To show it to you, you can check it writing print and type of A. So this will show class int, so that is integer. And float data types. Float data types are decimal value data types. So if A is equal to 5.8 or 5.58, you can see it's float data type. The next is complex data type. Complex numbers, like you have studied in your academics, are number with imaginary values, a real value part and an imaginary value part. So for this, you have to write like this: complex, complex. The real part, let me print 3 plus 5j, so 3, comma the imaginary part like 5. So let me show you how it looks. Print A and print the type of A. So see, 3 plus 5j is the number and it is a complex data type. Then the next we have is string data types, which are strings. The statements, what I was calling a statement, was a string. For this, you just need to add these and write whatever the statement is. Like hello world. So this is a string. This is a string and the hello world is the value or the data. But there are many methods associated with a string data type. These are some of the examples and there are many more. So let me show you. If you have a string and you want to convert it all characters to lower, so you have to use this function is lower. So let me demonstrate it. The methods need to be right like this. Dot is lower. So this will show that is your string is lower in all cases or not. So let me show it to you. It will return a true or false statement. So it returned a false because the H and the W is not all lowercase. So if you want to convert it to lowercase, you just need to remove this as, and a dot lower will show you what is the converted form of the A string. So let me show it to you. See, all the letters are in lower cases. And similarly, if you want to see if all the cases are in upper cases, so this will show you if all the cases are in upper or not, so false. And if I remove the is, a dot upper will convert all the characters in upper cases. See, it's converted hello world and the type is string. More functions we have is replace, swap case, capitalize. Let me demonstrate it. So removing this, replace world. What we need to find is world, and then we need to replace it with a statement called, we can call it learners. Okay, learners. So hello world will change to hello learners. See, the word has been replaced. Then we had swap case. So let me show it. Swap case. The swap case function will swap the cases all the cases which are in upper cases, all the characters which are in upper cases will convert to lower cases, and all the lower cases will convert into upper cases. So let me show you. See, H and W converted to lower cases and all others converted to upper cases. And then there was capitalized. So let me take a random string with all something and smaller. So if I want to capitalize the first letter of the string, so we can use capitalize, and this will give you the first letter capitalized. So see, the F word, the first word is capitalized. Then there are more functions like count, find, and rfind. So count will just count the number of iterations, the values that it are repeated. So let me show you. So let me create a sentence like I love coding, as coding is easy and coding is fun. So let me just find the number of values where coding was repeated. So I just need to write count and the string coding. So this will show you how many number of times the coding word was repeated. See, 3, 1, 2, and 3. Then we also have functions like find and rfind. So find will just find the word. So if let me find coding, if you want to find this word coding, so it will return you the index of the first occurrence where the code found this word. So 7, if you count, as the indexing starts from 0, so 0, 1, 2, 3, 4, 5, 6, 7. This is the place where it first found this word coding. But if you wish to find the occurrence of the word from its last position, so you need to write rfind, that is reverse find. So 36. If you count from this place to 36, it will get here. And there are much more related to string methods you can find on Google. So for this, go to your browser and search for string methods. String methods in Python. You can go to any website and see the number of methods with their usage. There are very large number of methods you can use. Now getting back to the data types, the string is complete. The sequence data types, list, tuple, and range. These are a collection of elements, but we'll learn about it later, like in the later part of the course. But these are just a collection of elements. Like here we have something like print A, and A can be a collection of items. So let it be a collection of fruits, apples, mangoes, and cherries. Oops. So if I run it, you can see this is a list. But we'll learn deeply about it later, in the later part of the course. Then we have binary types, which are bytes, byte array, memory view, and we have mapping data type, that is dictionary, in which we have key value pairs. We'll also learn about it in the later part of the video. And we have Boolean data types, which shows true or false, like what we returned in the string data type in the string method is lower or is upper. We got a false and we got a true. So okay, let me demonstrate it to you. So let a be a boolean data type, so it's true, and we can also print the type of a. So for this, if you want to declare a variable with boolean data type, only the first word needs to be capitalized and the rest must be in lowercase. So if a is equals true and b is equals to false, this is not valid, but this is valid, as the T is uppercased and here the F is not uppercased. So we can change it to F and now it is a valid statement. Then we have set data types, set and frozen set, where it is very similar to list, but it has only unique values stored in it, like a list with all values unique. So these were the types of data types which we learned and which we will learning in the further part of the video. Now it's time for a 1-minute exercise, where the question is to display the middlemost character of a string given as input from the user. If no middle index is present, then you have to display the character just after the middle index point. So what does this mean? Let there be this element which is ELEMENT. So there are 3 characters from this side and 3 characters from this side, and the middlemost character is this one, M. Again we have this GreatStack where 5 characters from this side, 5 characters from this side, but no character in the middle. So I have to print just with the character right after this middle point, that is S. And even if we have such type of string, so here S comes to be the middlemost element, so we have to print this. So let's go to the real coding. This is a very simple code, like we have to take just an input and prompt something like enter the string, and then what we need to do is we have to find the middlemost element. As you already know that how to traverse a string, suppose that there is a word like GreatStack, then this is the 0th index, this is the first index, R is at number 1, E at 2, A at 3, T at 4, S at 5, T at 6, 7, 8 and 9. This is how we use indexing in strings or in lists or in any programming language. We start the counting from 0 and go to the length of the word minus 1. So for this question we can have 2 types of strings. One of even length like this one is having thin length, and another which can have odd length, so let it be project, which is 0, 1, 2, that is of 7 length. So however I can write 7 for this. So in order to calculate the middlemost element, if the length is even, I can just find that the middlemost element is whatever the length function of string, that is length function just returns you what is the length of the string or the array that you are providing it, like the list you are providing it. So it will just return the length. So length of the string, that is 10 by 2. So if it is of even length, so 10 by 2 will be 5, and 0, 1, 2, 3, 4 and 5 will be this S. So yes, we can just print from this S followed by these square braces which says about the index that S at index this, which is the mid index, So the mid index, but this middle will be a float number. So to convert it, we can just do this integer of this mid. So this is the case when we are using some string of even length. But what if I am supposed to have some string of odd length? So it's 7, and 7 by 2 is 3.5. So integer of 3.5 is 3. So 0, 1, 2 and 3. Yes, it's working fine. However, if you are supplying this double slashes here, so this means that the length of s will be divided by 2 and will take the integer part of it. That is, not the decimal part will be included, it will only take the integer part. So we don't need this integer here, integer conversion here, and we can just remove these and print. So if the string is something like GreatStack, we are getting S, and if it is something like project, so we should get J. That is it. So this can be further simplified, however, like this function can be just removed from here, and this mid, so it will be directly replaced by it. And if we run this, see, we are getting the same results. So this is how we can use Python to reduce the code, and as you can see, we have completed this task which looked a little complex, but we did this task in just 2 lines of code, which is not possible in any of the language. But this is it. Type conversion. Type conversion means converting one data type to another data type according to our requirement. For example, converting a numeric data type to a string data type, or a string data type to a numeric data type, or just integer to float or float to integer. These are the examples of type conversion, the data type conversion. So there are two types of type conversion in Python. One is implicit type conversion, where the Python program automatically converts the data type of a variable, and another is the explicit type conversion, where you have to do all these things manually. So example for implicit conversion, let's take a variable a with a value 5. So we can print the type of a, and then we should change the value to 6.67.8, which is a float number. So the Python program will automatically change the type of a from integer to float here in the line number 5. I have increased the size of the IDE for a better view. So in the line number 5, a is changed from int to a float. So let me show it to you. Print the type of a and print a. Now this was first declared as an integer, but then when changed and converted to float, and then the value of a was 67.8. So this conversion is done by the Python program automatically. So this is called implicit type conversion. Then we have explicit type conversion. So let the value of a be a string containing 5, and then we can change a to int of a. Let b equals int of a. So this is the integer part of a, and move this, print type of B here. Also print type of A. Now run. Type of A was string, type of B was int, and if we print B, you can see 5 is printed. It's working. So this is explicitly changed to an integer data type. So this is called explicit type conversion, which you can use to manipulate the data type and change it according to your requirement. Now let's see something that automates and ease using Python in concatenation of strings and other data types with minimal effort, that are formatted strings. So let's take an example where we have A with John and we have B with value 4, which is an integer. So we need to print a message where something like John has 4 cars. Take this example. So A concatenation has 4 has, now we need 4 has B, which is the value B, and then cars, but B is an integer, so we need to type convert it, type conversion. So let's convert this into a string. Now this will work. So we need to print this message. Print. See, it's printed John has 4 cars. But this is a lengthy method. Like, this is a lengthy and the developer needs to too much of visualizations and type conversions for this method if you are taking a long string. So a shortcut method for this is formatting strings. So let's take a formatted string where we have to just write F and followed by whatever quotes you are using, either single quotes or double quotes. So now if you want to use a variable, you just need to add these curly braces and this will identify as a variable. So write whatever variable in these curly braces. So A, which is John, is has 4 cars. So 4 is again a variable which will be type converted automatically. So we can write just B cars and print message. See the same result. This is a shortcut way and more convenient to write. If you want to write a big or lengthy or any paragraph, so you can use these formatted strings. So if we go for the definition, formatted strings allows easy incorporation of variables and expressions within strings. They enable dynamic content insertion and facilitate string interpolation, making it convenient to combine text and variables values or in a readable and concise manner, like you can see. And the best thing is you can directly use it inside the print statement. So let me cut it and remove this message and just paste it here, and you can see it works. It will work with any kind of display technique that I show you, like using 3 quotes. It will work the same way. So let me paste it here, and if it is a multi-line comment, so let me do this. John has 4 cars. John has in the first line and 4 cars in the second line. It got printed exactly like I wanted it in the multi-line statement. Comments in Python. What are comments? Comments are non-usable or non-executable part of code that you can write to make the code more understandable or more readable. So how should we do that? Suppose we have a long code, like it will perform some action, it will print Fibonacci series for us. So we can just write something like to know that what are we doing. So for here, we are taking the first two terms. So here I can just write this first two terms, and to make it non-executable, I just need to write a hashtag, and this will be a comment. So you're saying that this line is now turned gray. So this is basically denoting that this line is a comment and will not be executed in your program. So for here, program to display Fibonacci series, to make it non-executable, I have just wrote this hashtag like this, and now this became a comment. Similarly here, what this piece of code do is check if the number of terms is valid. So for this, I have written this function or this thing. So this thing represents that whatever I have written here, this is the work that I am doing with these set of operations. And for the next operations, if there is only one term, return n1. So this is what here it is going. Or if you see here, generate Fibonacci series. So this is how I am generating the Fibonacci series. So as Python is already very readable and easy semantics code, so we should not write comments like this. Like we know that this is gonna print something. So print n1 will print something n1, whatever the value of n1 will be, it will just print n1. So we should not write that this print will print the value of n1. We should not use these type of comments. As Python is readable, we should not use so obvious type of comments like this. So for a good practice, we can just write those comments which actually means something and makes the code more readable and understandable, like this. Generate Fibonacci series, this part, the else part, will generate the Fibonacci series. And this is an end case, that is if only one term we have for the Fibonacci series. So if we run this, you will see that we will not get anything from these comments. How many terms? 9. So these are Fibonacci series where the first term is 0, second term is 1, and the third term is summation of last two. So 0 plus 1 is 1, and the next term will be summation of last two. So 1 plus 1 is 2, and similarly for any nth term, the value is the summation of last two. So 13 plus 8, that is 21, and the next term will be 13 plus 21. So this pattern is printed from this code, and here we can use comments like this. Arithmetic operations. These are mathematical operations that we perform for calculation in Python. So these are done using arithmetic operators. So we have addition, subtraction, multiplication, division, modulus, exponentiation, or floor division. These are all the operators that we have in Python. So let's take example for all of them. Let's take a variable a with value 19 and a b with a variable 5. So a variable c which shows a plus b. It's just that simple. And print c. Or we can directly use print a plus b. So if we run it, let's see 24, and we can also add subtraction, we can do subtraction, we can do multiplication, if you see, and we can do division. But if you need to do a floor division, like you want to get the floor value, so floor value of 3.8, 19 by 5 is 3.8, so floor value of 3.8 will be 3. The decimal part will be removed. So for this you can use double slash. So if you use double slash, you see it's 3, which is the floor value of 3.8. And then we have modulo. Modulo is this symbol. And this basically takes the remainder for you. So A mod B, 19 mod 5 will be 4. So here 4. Then also we have exponentiation, that is power. For that we need to use 2 star. So 19 to the power 5 will be this number. So let me take a smaller value like 2 to the power 3, which will result in 8. That is the output. We can change the variables. So the result will be calculated. See here, 32 to the power 5 is 32. So these are all the operations that we can do using these arithmetic operators. Once we are here with arithmetic operations, we need to know what is the precedence of the operators. So operator precedence means if a Python program is stuck at a point where 2 or more operations, arithmetic operations, can be performed, resulting in 2 different values, 2 different answers, what operation of operands should it calculate first? For example, if we have a condition 2 plus 2 multiply by 2, and this can be done in 2 ways. 2 plus 2 multiply by 2. So first one is 2 plus 2, that is 4, multiply by 2, which is 8. But the same thing is 2 plus 2 into 2 is 4, and here the answer will be 6. So which one is the correct answer? For this, if you have studied PEMDAS in your math, or if you have studied board math, Python works exactly the same way. Python also follows these rules. However, these two rules are exactly the same thing, but Python also follows this. For this, let me take a print statement with 2 plus 2 multiply by 2. This will result in 4 plus 2 6. So Python will result in 6. See, it's not 8, it's 6. So these precedence of the operators are followed in Python. So to be more precise on this topic, this is the precedence. Brackets, these have the highest priority, then exponentiation, then multiplication or division. However, they have no effect, so I wrote them together. And then modulo, which has a little less precedence than these. And then the addition or subtraction, which is again have similar precedence, as they have no effect on the answer if we use them together. So let's take a little complex calculation statement to understand it better. So moving this, and we can take 4 plus, can take 6 and multiply, and then brackets, which has a higher precedence, in which we have 2 plus 3 minus 1, and whole is divided by 4. So what will be the answer? The answer will be, first this bracket will be calculated, 2 plus 3 minus 1. 2 plus 3, which is 5, minus 1, which is 4, or we can take minus 2 first. So 3 minus 1 is 2, and 2 plus 2 is 4, which is the same thing. So 4, 6 into 4 by 4. Then we have the multiplication precedence. So 6 into 4, that is 24 by 4, or the division. So 4 by 4 is 1 into 6. So whatever you do, you will get 6, and 4 plus 6 at the last, which is 10. So we'll 10. But what is this 10? Is it an integer? It is a float number? What is this? This will be a float number. So let's see. Yes, this is a float number. Why? That's your task. As I have taught you type conversion, so think about it, that why it is coming not an integer, it is coming a float. Use your paper pen or do a rough calculation like where is the type conversion actually being performed. So this is how the operator precedence actually works. Now coming to the math module. So what is a module in Python? A module in Python, you can consider it as it is something very similar to a file, which has arbitrary named attributes or functions or variables inside it that you can use by importing them. So Python has a built-in math module that allows you to perform many of the mathematical expressions like trigonometric functions or representational functions or logarithmic functions, basic math operations, angle conversion functions, and many more. However, you don't need this module to find the absolute value or a round of value of a number by importing this. You can just do it using abs function or round function. Let me show you. However, it don't fall in math module, but let me show you. So without importing the math module, we can consider a value x equals 55.6, and we can just print x. So this is the same thing, 55.6, but we can also do one thing, that we can round off a value. So if we take, it's 56 because 55.6 is 56. What if I take 0.46? It will come 55. Yes, it's correct. So this is how Python will automatically round off a function for you, as this round off function will return the rounded off value or whatever the integer or the float number you give it. But what about the absolute value? You can take it as ABS, abs. This means absolute value of a number. So what is the absolute value? Basically, whatever number you give in this, it will return the positive number for that number. So if I am giving it 55.46, I will get 55.46, and if I am giving it minus 55.46, it will give 55.46, as the positive integer value is 55.46. So let me do this. See, I am getting 55.46, and this is the correct value. So now let's go to the math function. For this, first you need to do is import the math function. Import the math function. It's just this simple. Now your math module is imported and you can use it. So let me show you. It's like print and math.py, which is a number, the value of pi. What's the value of pi? So if we run it, 3.14 that we have studied. It's a little more accurate, however, but this is the value of pi. Also, we have the value of e, the Euclid's number, or we have the value for tau, which is tau. See, so you have these constants too in your math module. Then we have many more functions like math.power, math.square root, seal value, that is the top value. If a number is 55.5, so it will take the seal value and it will take 56. And we have the floor value, like if there is a number like 55.9, it will take the floor value and it will go to 55. It will return you 55. Then we have GCD, greatest common divisor, or if you call it HCF, the highest common factor. This is the same thing. So let me show you these functions, which are, so what if I take dot POU, power? It will take two arguments. First is 2 and the second is 3, which is 2 to the power 3, which means 2 to the power 3, and it will return you 8. So let me test this. Yes, it's 8.0. And then we can also have a square root, SQRT, which will take a single argument it's like 36, so it should come 6. Let me try. Yes, it's 6.0, the same thing. Then we have the ceil value, CEIL, which takes an argument 36 point something 876. So the ceil value for this number will be 37, a number just above this main integer. So let me try this. It's 37 is coming right. Then we have floor value, FLOR, which will just round off and it will come 36 as the decimal part will be ignored. So let's try this. Yes, it's 36. Then we also have the GCD. The GCD, which will take two arguments. One is the first number and second is the second number. So let us take 3 and 6. What will be the GCD of these number? Greatest common divisor will be 3, I guess. So yes, it's 3. And what if you are taking for 3 and 5? So the GCD will be 1. And yes, it's 1. So GCD is working fine. Then we have more of the functions like basic math functions that we covered, representational functions that we covered, or the attributes. And then we have angle conversions, where we have the math.degree, which converts to degrees if you are giving it radians as a parameter. Then we have math.radians, which will convert the degree to radians from this function math.radians. And let me demonstrate it to you. So if you want to convert something to radians, there is a degree. So just write degrees. And what is the degree? So if there's 30 degree, it will be converted to pi by 6 radians, and pi by 6 value will be not this. Actually, I just wrote it wrong. So for degrees, it will convert to degrees. So you need to provide an argument which is in radians. So we can just do the same function math.pi by 6. So what is pi by 6? It is 30 degrees. So let me try. It's 29.99996, which is close to 30, and whatever it is 30 degrees. So this is how we convert radians to degrees. And then we can also do for conversion from degrees to radians, for which we can use radians, and we can remove this and just write 30 degrees. So 30 degrees will be converted to radians, and it will be this value 0.52. We can also double check it like print and what is the value of pi. So pi by 6 should come this. So pi is, for example, 22 by 7, and then we need to divide this whole thing by 6. Pi by 6 is 30 degrees. So if we do, see the same answer, or however close answer, because the value of pi is it's not exactly 22 by 7, so it's however same thing. But if we use exactly math.pi, so we'll get math.pi by 6, which is the exact same thing. So this is how you will convert the angle conversion. You will do the angle conversions. Then we have more of the modules like trigonometric values, converting to sine, math.cos, and here you have to give the values in radians. So math.sine, math.cos, math.tan. So let me demonstrate it. Print. What should I do? Math.sine, and taking the values like what we can take, we have to take in radians. So math.pi, and sine pi by 6, sine 30 is 0.5, like 1 by 2. So it will come close to 0.5. So yes, it's exactly 0.5, like if we round off. So it's the same thing. Similarly, we can do for cos. Cos, it's root 3 by 2 if you calculate. And we have tan. What will be the value of pi, the actual radian for 45 degrees, which will be pi by 4. So what should be this result is nearly 1, which is tan 45 degree. So this is how you will perform the trigonometric functions, and more of some functions are logarithmic values, where log is for log of base 2 and log 10 is log of base 10. So if we write math.log, which is base 2 by default, so what if we give it 64? So the value is 4.15, as it took log of base e, but if we define log 2, it will take log of base 2. So this should be 6. Yes, it's correct. And if we take log 10, so let me take a greater number like this, and we can get it's 5. Yes, it's 5. So this is how you will implement the logarithmic functions. This is base e, base 2 and base 10. So this is how you need to perform the logarithmic functions. There are many more such functions that you need to study. You can just go to your browser and search the math module or Python math module, and you can just prefer any link, any of the link, like whatever the first links come. So you can just go, and you can see here we have arc cosine number, then also we have hyperbolic cosines, degrees, distance, Euclidean distance. To find Euclidean distance, we have math.factorial, we have exponentiation, and we have many of these: permutation, remainder, product, tan hyperbolic, and many of things. So you can go to the website, any of the website, or you can go to the official Python website and search for the math module and prefer any documentation to study more about these. Also, as I have told you earlier, functions are of general use, while methods are also functions, but they are specific to a module or something. So just like we studied in string methods, it's the same thing. So we imported the math module by writing import math, and then these all functions are associated with this math module. So we are using the dot operator to just be more specific that what is the actual function or the method that we want to use. So these are called methods. But you will be learning more about them and understanding it more deeply when we will be starting the object-oriented programming or the classes and objects in Python, which is in the end of this course. Now here we are at the point where things will start getting interesting enough. So let's learn about conditional statements. Conditional statements allows us to control the flow of a task on the basis of certain condition. Like it enables you to execute two different blocks of code on the basis of whether the condition is true or false. And these can be categorized in 3 or 4 you can take. Like there are if statements, there are if else statements, which defines that if a block is correct, if a block returns true, so yes, this block of code will be executed. And we have if else, where if a certain condition follows, so the block of code will be executed, else the other part of the block will be executed. Then we have if elif, which enables you to add multiple statements, multiple conditions, and then you can write multiple codes. Like it's not limited to 2 or 3, you can write multiple statements and then execute it. Then we have if elif, then we have nested ladders where we have if under an if else or if elif or anything, the combination of above. So let me demonstrate it to you. So let's take, there's a factor age equals 20. So the if block will be written like this, if, and then we have to write the condition. So age is greater than 18. Let's create a voting app. So if age is greater than 18, so you have to follow the indentation, like whatever code is written here in the same indentation, like it's written in the 4 spaces. So these all statements are considered to be a piece of block, piece of code, which are under this certain condition. So let's just print it. So let's print what we can print. Print yes, you can vote. Yes, you can vote. And just this, or we can write it multiple times to show you that the indentation works. So 4 times this. So if this age is 20 and 20 is greater than 18, which is a true statement, so this true statement, so if this is true, so this piece of block will be executed. So let's run this. See, here we get 4 times you can vote. So this means this statement is correct and we can just vote. All the lines that we wrote in this block of code belongs to a same code block, and this code block is under this conditional statement, and this statement will execute. So what if we write multiple statements? So let me show you. If, then we have to write the condition. If age is less than or equal to 18, then we have to follow the colons, and then we have to define with indentation the real thing. So pen, what should we print? We can print go study. And then just following this, copy and paste. We have to follow the indentation. If we don't follow the indentation, then this part will be treated as a single block of code, and then this will be executed. So I will just show you. Before that, let's check. You can vote as the age is 20 right now, but what if we change to 2? So if we are changing it to 2, so let's run this, go study. And what if we miss the indentation now and change the age to 22? So now this will be followed. So this block of code will be executed, and then this block of code will not be executed as this statement is not true. Then this will be go study will be executed. So let's try this. See exactly what I told you. So you can write multiple if statements like this. And then we have if else statements. So what is if else statements? This is basically like you have to write else. So this shows that if a particular condition is false, if this is not true, then you have not to follow this piece of code. You have to do this task. So let me show it to you. If this statement is false, do this. So run, you can vote as age is 22, which is, so this statement is true. And if age is 2, so this statement is false. So if the statement is false, go and do this. So run, see, go study 3 times. So this is how if else work. Then we have if elif else. So what is this? Basically, we can write multiple if statements in a single piece of control code. So what does this mean? If age is 18, greater than 18, yes, you can vote, unless there be a condition which is elif, then we have to mention the condition which is if age is equal to what can be the age. So equal to 18, let's take this 18. So we can print go apply for ID card. Then we have else statement. So this is if else. We can write multiple statements. So we can also write elif and conditions. So if, but in this case we don't have any other option, as something can be less than, greater than, or equal to something. So this is basically greater than, this is equal to, and this is less than. So go apply for ID card. Let me copy this piece of code and paste it 2 or 3 times. So now if I run this, go study as age is 2. So this statement is false. Okay, this piece of code will not be executed. Then this will be checked. This is also false. So this piece of code will not be executed, and else this will be printed. So what if age is exactly 18? So apply for ID card. Here this statement is false. This code will not execute it, and this statement is correct. So this part of code, this piece of code will be executed, and as any of the statements in this ladder is true, so this will execute and end. So to show it on a full screen, we have age, we have some conditions related to this, and then the piece of codes, the code blocks which are executed according to the condition. So this is why this is called a conditional statement. So now the last thing, we have nested ladders. What if we have more than 2 variables or something that you need to check 2 random conditions which are like nested in them? So if age is 18, and let's take a variable citizenship equals true, that is a boolean. So if citizen is true, so if age is greater than 18, and if the citizenship is true, equals to true, or we can just write it like this, if citizenship, like if true, then we have to print this statement, and these statements will be indented. So here else we have to write like print something like you are not a valid user or citizen. So let's run this and make this false, make this 19. So oops, the spelling mistake, Python is case sensitive, this is F, capital F. So if citizenship is false, so let's run this, and you are not a valid user as the citizenship is false. So if age is greater than 18, this code is followed. Yes, age is greater than 18 if true. So this piece of code, this whole piece of code will be executed, this whole thing. And if this is executed, then we have a nested if else ladder in it. So if else is there, a nested thing. So if citizenship print this, else print this. So if we have citizenship, let's try this, if true. So if age is greater than 18, okay. Citizenship was false, so this was not executed and it went to this else block and this was executed. But now I have made this true. So if citizenship, this code of block will be executed. So let's try this and see, it is executed. This is how you have to think the logic about how to build a if-else ladder, a nested ladder like nested if-else statements. Or I can also have something like if and elif nested. Like here I can also nest if and elif statements. So however, this is not possible in this case, but we can also take a condition like elif and some statements, and then we have to perform some operations. We can also do that, and it depends upon what strategy or what project you are working on. So this was all about the conditional statements. Now getting to the comparison operators. So basically these operators are used to compare whether two elements are related or not to each other. So what are the relations? So the first one is equals relation. These are only the 6 type of relationships in a Python code. So we have operator equal to, which is equals. So it just verifies that if the both elements are equal or not. And then we have not equal to, then we have greater than, this symbol, then we have less than, then we have greater than equal to, and we have less than equal to. Basically all these comparison operators returns in a true or a false. That is all the work done by this thing is just a true or a false. It returns in true or false. We studied in the if else or the conditional operators. But to just check the real return thing of these comparison operators, let me demonstrate it to you. We can just write x equals to 5 and we have y equals to 7 or something. Then we can just print if x equals to y, which is not true, which is false. So it should return false. So let's try this. Yes, there is a false. So what if I write x is not equal to y, or x is not equal to 5? So this should be returning false. What if x not equal to 7? This is true, and x not equal to y. This is true. And what if some more of things like less than equal to, which is again true, and greater than equal to, which is false. So you can do this, or just greater than, it is false, and just less than, it's true. So this is how all the comparison operators return whatever you write in Boolean. So basically it returns a Boolean code. Now logical operators. Logical operators are used to perform logical operations on Boolean values. So there are three types of operator: and, or, and not, which is very similar to whatever we have studied in physics, like AND gate, OR gate, NOT gate. It's exactly the same thing and works exactly the same, but with the exact same keyword. Like if you want to use an AND gate, you have to write A and D. So these are the table. If we have two different values and both are false, so the resultant will be false. And if two values are false and true, then it's like if any one of the value is false, so the resultant will be false, because both conditions need to be filled true. And if both of them are true, only this condition will be executed and all the others condition will be rejected. So then we have OR table for OR gates. or the OR operator. So for if you are using an OR operator, then any one of the Boolean statement should be true. So if both are false, then the resultant will be false, and if any one of them are true, like in these conditions, so the resultant will be true, or the code block will be executed. And then we have not table. So here, whatever you will give, it will just inverts its value. So let's demonstrate this using an if else statement. So if you can give x is equal to 5, x equals 5, and a and d, y equals 7, then print anything like yes. But we have to declare x and y. So x equals to 5 and y equals to 7. Now after running this, we can get a yes, that yes, this is executed. And then we can change the value of y equals 6. So this is a true and a false, and true and false for AND table, true and false will be false. So this code will not be executed and nothing should be printed. So let's run this. See, nothing is printed here. Similarly, if we set y to 7 and x to 4 or something, then again this condition will not be followed, as one of the condition is false, and this will not be printed. So this is how the AND operator works. Then we have the OR operator, where any one of the statements of the Boolean statements should be true. So here x equals 4 not true, y equals 7 is true, so this will be printed yes, yes. Then if this is false and this is true, then yes, this will be printed yes. And if both are false, then we have nothing is printed. So this is how the OR operator used. Then we can also see a scenario where x equals 5 and not y equals 7. So this will take if x is equal to 5, okay, we used an AND operator, and not y is equal to 7. So y is equal to 7 is false here, and not false is true. So this is false, and not false is true. So true and true is true. So this will be executed. So let's try this. This is executed now. So this is what is the working of a NOT operator. We can also change this. So 7 or make this 4. Then we have NOT. We can run it. We got a yes because x is equal to 5. This is false and not false is true. So true and true, which is true according to the AND operation. And then we have this. Also, if you want to use just the NOT operator, you can just remove this, and if not x is equal to 5, which is however the same thing as this one, but you can use this. If you're writing a long code and you want to make your code more readable, you can do this, which will work exact the same way. So this was all about the logical operators. Now heading towards the looping statements or the loops. So if we are writing a particular block of code which we need to perform a particular number of times or many number of times, so it is not a good practice to just copy it and paste it again and again. And also it is not a good effort to make. So for example, let's take a thing that we have to print hi. So if we want to print it a single time, so that's not a big issue, it's just hi. But what if I want to print this 5 number of times? So I can just copy it and paste it 5 number of times. So if we run this, we'll get 5 number of times high. But the challenge comes when we have to print this or print a particular operation around 500 number of times. What will you do then? So, or we have to print it 50,000 number of times. So how will you do it? You are not supposed to copy it and paste it 50,000 number of times. So here comes the looping statements. In Python, looping statements allows us to create a block of code that can be repeated many number of times. Basically, they provide you a way to iterate over a sequence or perform a particular set of instructions until a given condition is met. So there are two main types of loops in Python. The one is for loop, the second one is while loop. The nested loops are exactly the same thing like we have studied in nested conditional statements, where in conditional statements we have that a flow control will be decided on the basis of certain condition is met or not. Those conditions can be indented or nested, that one if statement has another if statement within it, so it's nested. That's the same thing about nested loops. One loop is nested under another loop or loops under loops under loops. So getting back to the for loop, a for loop is used when we have a particular sequence. So it is used for a particular sequence if we want to access a particular block of code some particular number of times that is predefined. So for example, here the challenge was to print high 5 number of times. So we can just remove these and we can use a for loop. So how can we use a for loop? It's just that simple that we have to write for, then we have to write an iterative variable. So what's an iterative variable? An iterative variable is a variable that counts the iteration. So what's an iteration? Suppose we have a particular line of block of code, something like this. Let's suppose this is a code, this is a piece of code or an instruction, particular instruction, and these instructions has to be covered 100 times. So one time the whole instruction is covered or executed, that is counted as first iteration or one iteration. One time this whole instruction is followed, that is called a single iteration. So for iteration counter, that can be, let's take it I. For I in, what can be it be in? So it can be in a range. So range of 5 followed by these colons, and then everything that belongs to this code needs to be indented. So for I in range 5, print high. Now what does this range function actually returns? Actually it returns a list. So if we have range of 5, it will return 0, 1, 2, 3, 4 and nothing, as we have already filled 5 elements. So range 5 will return from 0 to just one number less than this number. So 0 to 4, 5 elements. And if we pass 2 arguments in this, what will happen, like 5 and 10? So it will just start from this, rather than starting from 0, it will start from 5 and go just one digit back to this 10. So for range 5 to 10 will return 5, 6, 7, 8 and 9. This thing. So commenting these out, and let's try what will this return. So just run it. We are getting 5 times high for range 5 to to 10. For 5 we'll get this. So for 5, for the first iteration in range 5 to 10, in this whole range, for this whole range, for I, for this, print high and then automatically increment. So it will come to this, and for this in this range, print high again and automatically increment. Then for this in this whole range, print this, and similarly for 8 and 9. We can also verify this variable or this iterative variable by just removing this high and writing I. So if we print this, we are getting 5, 6, 7, 8, 9, which confirms this pattern. For 5, for this 5, print I, print the first thing that we returned. So it returned 5. For I in this, so it will auto increment to this, and for this in this whole range, just print the I. So print the whatever it's returned, 6. So 6 is printed. Similarly 7, 8 and 9. Also, if I just remove this, and now it will follow this, if I run this, you will see that I got 0, 1, 2, 3, 4, 5, which matches this pattern. That is, for this, for the first iteration, for this, print I, and for this, print I, for this, auto incremented, for this, print I, similarly for 3 and 4. Or if we have a list predefined, so let the list be nums, a set of nums, which can be some random numbers like 54, 23, 876 and anything, 133. So just like for let me remove this range and write nums. So for I in nums, for the first iteration in nums, print whatever it is on the first iteration for this. So for the first iteration we have 54, then print 54. For the second iteration we have 23, so print 23. For the third iteration we will be here, and for the fourth iteration until the list is complete. So let's try this. Yes, we got the list back here, 54, 23, 876 and 133. So this is the magic of the for loop. Now this is also too dynamic. If we increment like this whatever is in the list, if we increment it, adding it 45, so we have to make no changes in code and we can just run it and see everything is printed. It will automatically calculate the length of this list and do whatever operations you have given or whatever you want to perform. And now moving to the while loops. So what are while loops? A while loop is used if we want to repeat a particular block of code until a given condition is met. It sounds similar like the conditional statements, where we have a particular block of code that should be executed if a particular condition is met, like the if statement. So very similarly, we have to write the while, and while a condition is met, that means we have to define the condition. So let me take a variable x equals to 5, and while this x is less than 10, that is our condition. So while x is less than 10 colons, we have to perform what set of instructions we can write. A simple instruction can be print. So print high. But how will this x get incremented as, or how will this condition fail? As x is equal to 5, so it is a constant and it is less than 10, so this condition will be always true and this loop will run infinitely. So for this we can just increment x, like x is equal to x plus 1. Now x will be incremented and it will be printed 5 times. So let's run this and see. 1, 2, 3, 4, 5. We have 5 times high. So this is how our condition is followed. Or if we do it x is less than equal to or anything we can do. And as I have told you that these type of comparison things return just a true or false, so it will just happen like this. While true, do print high. So this will how it works. But if I run this while true, that means while everything is true, which is always true, so it will run infinitely. So you should not write a code like this. It's just for your understanding that what actually happens behind the scene, and this true will be changed to false once our condition is failed, that is x less than 10. X will be incremented here. X is equals to x plus 1. It will be incremented, or I can also print x to show you. So it will be incremented 5, incremented to 6, 7, 8, 9, and when it will be incremented to 10. So 10 is less than 10. It is a false condition. So while false, that is all the statements that we wrote, everything will not be executed. So this is how your conditional looping statement or the while loop will work. But then we also have something called nested loops, where we have loops under loops. So let there be x equals 5 and y equals 3. So while x is less than 10, and let's just remove this, and we can add for loop or while loop or anything that we want for I in range x. So for this, print, what should we print? We should print x, or let me make this a little more like 7. So now let's print this. We are getting a finite number of 7, as x is equal to 7 is always less than 10. So we also have to increment this. So we can just increment it after this for loop. If we write x is equal to x plus 1 here, it means for this iteration, for every I in range x, the x will increment. But if we remove this, like indent it in this while loop, so now this lies in this while loop. See, it lies in the while loop, not in the for loop. So for every while loop iteration, it will increment x, and for every I in range x, it will not increment. So let's run this and see. 7 times 7 was printed here. 1, 2, 3, 4, 5, 6, 7. 7 times 7 was printed as x was 7. Then x was incremented to 8, and for I in range 8, that is 0, 1, 2, 3, 4, 5, 6, 7 until 7. So that is 8 times. 8 times x will be printed, that is 8 will be printed. So 8 times 8 was printed. You can count 1, 2, 3, 4, 5, 6, 7, 8. And then 9 times 9 will be printed here. As x will be incremented to 9, 9 is less than 10, which is true. So 9 is less than 10, true. So this whole thing will be printed. And for I in range 9, print 9. So 9 times 9 will be printed, and then x, that is 9, will be incremented to 10, where we'll get a false, as 10 is less than 10 is a false. So this loop will break and the execution will be end or over. Then we also have loop control statements, that are these break, continue, and pass. So the break keyword terminates the loop without letting it complete. So for example, this is whatever it is. So if I write here except this, that you can break, so right after the first execution, like after this execution, after the for loop execution, it will find the word break, and without seeing that x is less than 10, okay, it entered, and without seeing that whether this condition is false or not, it will break. The while loop will break. and this will not be incremented, or whatever I write here like print t or terminated, this will not be executed. So let's run this and see 7 times 7 was printed while 7 is less than 10, that is while true. So enter in this, and for I in range 7, print 7 times 7, okay, print 7 times 7, okay, it's printed, then break, and these all things are not executed as there is a break keyword which terminated this while loop. Then we have the continue keyword. Continue keyword is just opposite to what the break statement did. So continue keyword forcefully commands the loop to go to the next iteration. For example, let me make this 10 and remove this and this too. So for I in range 10, I want to print I, but now I can just give one thing, that if a particular state, that is I equals to suppose 5, then we can just do that print I. We cannot print I. Okay, we can print I, and without I is equal to 5 we cannot print I. So it will just iterate over I in range 10, and whenever I will be equal to 5 it will print I. So let's try this. See, it's just getting 5. Also, if I can just make it like this, else perform this, and here I can just use continue. So what this code will do is, for I in range 10, for 0 to 9, the list 0 to 9, it will just print I every time. It will just check that I is equal to 5. No, it is not equal to 5. So print I. If whenever it will get to 5, so I is equal to 5, yes, then you can continue. You have to perform nothing. You can just continue to your next iteration. So if we run this, you can see 0, 1, 2, 3, 4, and 5 was not printed here. 5 was not printed as it continued. Also, if like the iteration is skipped, so whatever you write after this, so let it be print hi or hi there. So whatever is after this, this will not be executed, as this point says that you can just continue. So let me run this. See, there is no hi there, and 5 is not there, as 4, and after 4 I is equal to 5, it says continue, and this will not be executed as the iteration is skipped from here, and then it moved to 6, 7, 8 and 9 by this. So this is the use of continue. It is used to skip an iteration. Then we also have the pass keyword. So the pass keyword is just a keyword that says to do nothing, as the name suggests. So it is used when we have to provide a statement syntactically but need no action to perform on this. So we can just make it like, if we remove this, so now I have to write something. It's an error. See, here it is showing an error. So for this we can just write pass, that just to bypass this error, that yes, there is no error, I have wrote something, but this means absolute nothing. So just run it and see 0, 1, 2, 3, 4, and for 5 it just passed, say nothing. If you hover over it, you will see what it actually means. So this will just pass and do nothing. It just says that I am syntactically correct and you have just to pass, because I don't want to perform any operation for this. So these were all about the loops and loop control statements. So now it's time for a 1-minute exercise where you have to print this pattern using the user input. So you have to take the user input and print this pattern. So how can we print this pattern? What we can say is every iteration of these lists, like these all looks like a list. So this looks like a list of lists, and every list has, like, the biggest list is, every list is starting from this digit 1 and from the range 1 and ending to whatever the biggest number is, which is 5 here, that is the user input. So 1 to 5, and then for the next iteration it is just reducing its size. So we can decode it as, initially its size was this 5, 1 2 3 4 5, then it was for iteration 1, then for iteration 2 the size went from this n to n minus I, that is the iteration. So this is the first iteration, so the size became n minus 1. And then for the third iteration, the list number 3 here, we are getting n minus 2, and then here we are getting n, which is was 5, minus 3, then here n minus 4. So this is how the pattern is getting reduced: n minus 0, n minus 1, n minus 2, n minus 3, n minus 4. So if you want to try to code this, the first thing we get is n, which is a user input, so which is an integer user input. So we can just do it like input, and you can prompt something like enter any number. So this is your prompt. And now for the logic part, you can just do, as we can see here, we have a list of the total size. So this is printed 5 times, 1 2 3 4 5. So the upper loop will go for I in range n. This loop will allow me to iterate 5 times, or whatever the number is. Let the number be 5 initially. So this loop will allow me to iterate 5 times, 1 2 3 4 5. And the next thing I need to do is just print these numbers. So these numbers will come out of the range function, and I just have to print them. So what will be that? That can be for j, because we are already using I, for j in range n minus I. However, it will start from 1 and it will go up to n minus I. So I have to give +1 for that, as range returns a list which is one number just less than this. So I need to write +1 here like this, and then minus I wrote it because you can see that for every iteration, for the first iteration, that is the 0th iteration, n minus I, that is n minus 0, is the total length of the string. Then n minus 1 is the total length of the string. Then n minus 2 is the total length of the string. So for 0th, n minus 0. For 1th, it is n minus 1. For second, it is n minus 2. Similarly, for every ith, it will be n minus I. So for this, we just need to print j. But we don't want any new spaces here, like a new line. We want it to end with a space, a blank space, not a new line. So this is how you should write this. And after the whole list is completed, like this whole list we have displayed, then we need an extra line. So for that, you can just do that. When you will come out of this for loop, you can just print a new line, which can be like this, or you can just write like this, but no matters how you write, it will work. And then just run it. See, enter any number, let it be 5. If we enter, we are getting this. The same thing. Also, if I run this again, if I am giving 9, so this is the list. So congratulations, you are done with your first Python real world code. Now it's time to get your hands on the real list, diving in to get a deep understanding of it. So what are lists? A list is a versatile and mutable data structure used to store collection of elements. It is denoted by square braces and allows us to store heterogeneous data types. So what does this mean? This means that we can store different data items or different data types in a list. So let us take a list which contains heterogeneous data types. So the first data type can be an integer, the second data type can be a float number, the third data type can be a string, and the fourth data type can be a boolean. So also a list can also have a list inside it. That means list can contain integers, strings, booleans, and even other lists. So let's take an example where we also have a list of some characters. So it's A, B, and C. So this can be a list. So let's print this list and see if it works or not. Yes, it works. So this shows that a list has heterogeneous data types stored in it. It is not restricted to store all items of a single type, unlike some of the programming languages like C++ or Java. So lists in Python support operations such as appending, that is adding some element to the end, removing an element, or accessing an element using indexing. So what does this mean? Indexing. What is indexing? Indexing is creating a position of elements. So the first element is this, the second element is this, the third element is this. So these all are at a certain position, and what I'm calling it first, second, and third in Python or in a programming language, this counting starts from 0. So this element is at 0th position, this element is at position number 1, this element is at position number 2, at 3, and at 4. This whole list is at 4. So how to access them? We can just add these square braces and write the index number. So if I want to access the 0th element, let me write this 0, print list 0. That means print list, and I want to trigger a specific element at 0th position. So if I run this, I am getting 5, which is at 0th position. And similarly, if I write 1 or something 2, so if I run this, I'm getting str. Or let me take something like it's 0, 1, 2, 3 or 4, so I can just write 4. However, this list contains 5 elements, that is 1, 2, 3, 4, and 5. But as the indexing is starting from 0, so we have 0, 1, 2, 3, and 4. At the 4th position, we have this. So list of 4 will return this list. So let's run this and check. Yes, we are getting it. Also, as this whole thing is now a list, so if this is a list, this whole thing is a list. So we can do the same thing and write braces and access the elements like 0, 1, 2. So I can access the first, that is B. So let's try this. And yes, we are getting B, as this list of 4 returns a list of this list. So this whole thing means a list. So this list, and I want to access from this list the element at the first position. So this is how I can access this element or this list too. So these are nested lists. So let's learn more about lists. We have 2D lists, range, sets and tuples, which are same as lists, but we can take it as variations of lists. So what are 2D lists? 2D lists are the lists in which we have a list at every index of the list. So every element of the list is a list itself. So if we say it, let's take, we have a list where at every position we have a list. So it can be a list at position number 0, and then we have for 1, and then we have for 2. So this is a 2D list. Let this be the first one, can be 1, 2 and 3. The second one can be 4, 5 and 6, and then the third one can be 7, 8 and 9. So this is called a 2D list, where at every element we have a list itself. So this is a 2D list. Also, talking about the traversals or the indexing, if we print something like list of -1, so this means that the list will be traversed from the reverse direction. So this list is, this element, this whole element is at position number -1 from the back side. So if I run this, we are getting 7, 8, 9. Similarly, -2, 4, 5, 6, this one. And also, if I add colons, so let me add these colons and write 2 or 1. This means that start from the 0th position and go till this position. So we have start from 0th position, we can mention 0 or we can just remove it, it doesn't matter. So this one and this one will be printed. So these got printed as I mentioned 2 here, but if I mention 1, so only from 0 to this position. So 0 to this, don't print this, only this. So for 0, this is it. And if I mention 2, you can see that these elements, the first one, the 0th and the 1 is printed. Also, if you specify the position from this point, so let me mention 1, so it will start from 0 and 1, it will start from 1 and go till the end. We don't have to specify the end. So just run this and yes, we are getting the first element at position number 1 starting from this point going to the last. So this is what we get. Then you can just experiment, like removing it and going to -1. So this will print the first 2 elements, as the -1 element will not be printed. Just before this one will be printed. So just before this is this. So these 2 will be printed. And starting from -3 or -2, we'll get this 4, 5, 6. Starting from -2. So -1, -2. This one starting from -2 at this position, ending to -1, this position. So between these we have just this thing. So this is how you should traverse using Python lists or using the negative numbers. And just don't forget that -0 or +0 is the same thing, that is 0. So you don't need to specify minus sign or plus sign before 0. So the same traversing technique can be used in lists. So let me access a list of this point, that is 0 and 1, list of 1, which returns a list. This list it will return. So accessing any element of this list can be 0, 1 and 2. So I want to just access the 1, or that is this position, the 5. So if I run this, I'm getting 5. Or if you will print just the list, so I will get the whole list. So this is how you should access any element of the list, like this. Also, this indexing can be used for modifying the elements. So let me print the list like this and just writing it like a different number, that can be 67, and then printing the list will get me the whole list, where this number, list of 2, 0, 1 and 2, and the 0th position, so this position 7 will be replaced by 67, which is it. So this is how you will access the elements using indexing. Then we have the range function that returns a list. However, I have taught you this already, but just for a short revision, it's range function which will take 1 parameter or 2 parameter like this and return a list of the elements starting from this position, ending just 1 before this position. Or if I remove this, it will start from 0 and end to this position. So those are called range. And then we have sets. So sets are data types where the elements are unchangeable and unordered. Also, all the elements of the set must be unique. Okay, so we understood that set is unchangeable and unordered. That is, it does not follow a specific order. Does this mean this is a constant? No. Actually, the unchangeable word means we cannot change any element, like accessing any element and changing its value like we did in lists here. We cannot do this operation. We can just add, update or remove something. So what does this mean? So how to declare a set? A set, like let be an example be set 1 equals the same thing we did in list is this, but for sets we need to define it using curly braces, this one. So now this will be a set of some random numbers like 1 2 3, and I need to print the set. So print set, and let's just run this class set. Okay, I missed the 1, so it's set 1. Let's run this. I'm getting the whole set. But unlike lists, you cannot access using elements like the positions. So set 1 of 0 will give an error. So let's run this. Yes, there is an error which says type error. Set object is not subscriptable. That means that we cannot access set using subscripts, that is this 0. So it will just print like this, subset like set of 1. So our set 1 is printed, and in order to add something we can just use dot add. We have many of these methods, so if you write dot you will get plenty of methods for this, where the pop will just remove the last element and everything, dot copy, dot union, many things. So let me show you dot add. So what if I add something like 8? So let's run this. Okay, actually I did something wrong. I just need to remove this and do this operation and then print the set1. So here 8 is added. Add 8. Then if I want to just repeat this step and add 5 to this, or again if I want to add something like 0, if I run this, I will get this, which confirms the unordered behavior. We are appending it in 1, 2, 3, then 8, 5 and 0, getting sorted as 0, 1, 2, 3, 5 and 8. That means it is not following how we are adding it. Very similarly, if you want to just remove something, so you can just write remove and then you have to write the element like this. So I am writing 2 and so 1, 2, 3 and 2 will be removed. So 1 and 3, what I am left with. Also at the same time it is getting sorted. Then we also have a similar thing that is very useful. That is, if I have set 2 which contains, let's suppose 4, 5 and 6. So if I want to just update this set, so I need to write set1 dot update with set2. So what this will do, it will update set1 with set2. So whatever these numbers are, it will just add this set2 in it. So let's print this and see. Yes, we are getting all the elements. But what if we have something in common? So let there be something in common, which is 3 and 4 that we have in common, or let's suppose 5 also that we have in common. Then it must remove these duplicates, as in sets we cannot add duplicates. So if I run this, see 1, 2, 3, 4, 5 and update means whatever the new element is, just add it to the set. So 6 will be updated here. So 1, 2, 3, 4, 5 and 6 like this. So this will be the new set1, as set1 is getting updated with set2. So there are many methods that you can just see, or you can just explore yourself or study about them on internet. So just go for it if in case you need it. Then we have tuples. Tuples are immutable. That means it's something like a constant that you cannot delete or remove some elements. So let's see this. Let's suppose we have a tuple tpl, and to declare this you can use two ways. First, you can just write it whatever is the list. So if we have a list 1, 2 and 3 or 4, this will be a tuple. So if I print the type of this tpl, I will get a tuple. The second thing we can do is just add these braces. So this is also how you should declare a tuple. That is a tuple. So print just tpl and see what happens. We are getting tpl like 1, 2, 3, 4. Also, let's suppose we have two tuples, tpl1, tpl2, which can be ABC. So A, B and C. Oops. So this is a tuple. Now if I want to append this, so I just need to write that tpl. However, I cannot delete an item from a tuple, but I can just do tpl1 plus, or let's take a sample, tpl equals tpl1 plus tpl2. So it's tpl, print the tpl So let's run this and we are getting the whole tuple. So we are basically creating a whole tuple, a whole new tuple, which consists of this tuple and this tuple. As tuples are immutable and we cannot change it or modify it. So the only thing we are left with is creating a whole new tuple. But unlike sets and like lists, we can just use this square braces and just access it using the index. So what is tuple? This is, so let me access the third element, that is this. So let's run this and I am getting it. 4 0 1 2 0 1 2 3. This element is the element at the third index or the index number 3. So again we can perform operations like print the tuple from 0 to 3, that will be this, or from 3 to the end, that will be this, and similar operations like I taught you. Then we are here with list methods. So lists has some method by default with it. So the first one can be append, which I have already shown you. Then we have clear, which removes all the elements from the list. We have count, that returns the number of elements with a specified value. So what does this mean? Let's suppose we have a list ls which is equal to some value 1 2 3 4 1 2 3. So if I will use this ls dot count, then I want to count for 2, like how much times this 2 is repeated. So let's print this. So let's run and see. 4 times 2 is repeated. 1 2 3 and 4. 4 times 2 is repeated. Similarly, if I search for 1, I'll be getting 2. If I count for 6, which is repeated 0 times, I'm getting 0. So it will count how much a particular element that you are passing as an argument is repeated in the whole list. Then we have this extend method, which just adds the elements of a list to the end of the current list. That is, if we have two lists, ls and ls1, which is equal to 5963. So if I write ls dot extend ls1, so this will return a list which will have the ls extended by this. So let me perform this operation first and then just print the list ls, and what we get is the whole new list with these 4 numbers, the elements of the second list extended to ls. Then we have the index function, which returns the index of the first element with a specified value. Like whatever value you will specify as the parameter of this index method, it will return you the first occurrence of that element. So to check that, let's suppose we have too many 4s here. 4, then again we have 4, and again we have 4. So we have too many of 4s, and also it is extended. So let me find from ls dot index, which is here, index of 4. So what will be the answer? I'm printing this. So just let me remove this and just print this. It is 3, 0, 1, 2 and 3. this is the first place where this element was occurred. So basically this is the first occurrence of the element with this specified value. And then we have insert, which adds an element at a certain position. Then we have pop, which removes the element. And then we have remove, which just finds the element and remove it. Then we have reverse, which reverse the order of a list. Like whatever the list we have, print ls, we can just print ls dot reverse, or like doing this operation and printing the ls again. See, it's reversed. Whatever the value was, it is reversed now. And then we have dot sort. So ls dot sort, if I remove this and write sort here, ls dot sort. So now these all numbers are sorted. As you can see, this was our old list and now it is a sorted list using this sort function. There are many more functions like this. You can just go to your browser and find for list methods in Python. Just search for it and go for the first website you get or whatever website you want, and you can see there are a number of methods. Now here we are unpacking lists. So what is this unpacking means? Unpacking is basically unpacking the elements of the list. So let's suppose we have a list that is ls equals some fruits like this: apple, mango, bananas and oranges. Apples, mangoes, bananas. Okay, spelling mistake. These. So one thing we can do is we can just get fruit1 equals list of 0, and then we can access or fr2 equals ls1. Like this we can just unpack the elements of the list and we can use it. The better thing we can do is unpacking it with their names. So what can be their names? The names are apples, and then we have mangoes, then we have bananas, then we have oranges equals ls. So if I want to see, so print apples. So what are apples? So these are apples. So the first one is this element, the second one is this element, the third one is this element. Also, if I want to just take this apples out and I don't care about the rest, so I may not just declare them and just remove it and use a star and write others. So everything are others. The whole list, this part of the list will be declared as others, and apples are apples. So let me print others. So if I run this, apples are apples and others are the list of all those things. Also, it is not mandatory to match any spelling, as you can get confused because of this. If I remove this and name it at A, or if I remove this and name it as fr1 or fruit1, I will get fr1 as apple. See, fr1 is apples and the others are whole these things, or anything like ot and ot. So if I run this, see, it does not matter that you are writing any specific name for the variable. You can write whatever you want, just follow this star. So this is how you should unpack a list and use it like if you want, like whatever you want, you can just use it. So this was all about the list, and let's move to the next topic. Now something very similar to sets or lists but a great value addition are dictionaries. Dictionaries are built-in data structure that allows us to store data which are unique, mutable, unordered key value pairs. So what are key value pairs? This means that for every key in a list, we have a set value. So every value that you want to store in a list is associated with a key. So we can just access the key and we can search the value with the help of the key. Similar to sets, it is unique, mutable, and declared using curly braces. So let there be a dictionary called car, declared using curly braces, and it has some properties which are keys and keys associated with values. So we have a key called name, which can be something like Ford, the brand name. Then we have to use comma in order to associate properties for the list. So let it be something like model. So its model is Mustang. So let it be Mustang. And let there be another field called mileage. So MIL. This will be associated with something 12. Okay. So now this represents that car is a dictionary which has keys called name, model and mileage, which are associated with some values that are Ford, Mustang or this integer 12. So the keys or the values can be anything. It can be heterogeneous. So there is nothing like restriction that you have to just associate some similar data types or use it for keys or values, anything. You can just put it heterogeneous. What makes them different from sets is that they have key value pairs. That means for every key it has a value, unlike sets. These type of data structures are generally used for mapping. For example, we can have something like encoding, decoding messages. So the encoded, decoded messages can be something like if you type some numbers, it will convert it to letters. So this can be represented as one will represent the character A, 2 will represent the character B, or something like this. You can just fill it all the way long. So this is basically mapping of a key to a value. So once we are here with a dictionary, we can just print the dictionary. So for that you have to write just print the dictionary name car, and here you can see the whole dictionary. This is the whole dictionary. If you want to access the key, because everything moves around the word key value pair, so how to access the keys to get the values? For that, very similar to lists or sets, you can just add these braces, the square braces, and write the key. So what is the key? Let's suppose I have the key name. So car name, if I access it, I'm getting Ford. So I'm just giving the dictionary name with the key name. So I'm getting the value for this. Car name access Ford. Okay. And another way to do the same thing is .get method. .get, then again this is a method, so you can use these braces, like you have to use these curly braces, the small braces, and you have to write the name, so the name of the key. So I want to access the name key, so I just want to run it and see I'm getting Ford. So basically there are two ways of fetching the data of your dictionary. So one is this, but what's the difference? Like I can do both things, car.getName using this method, and also I can do car name. If you are doing this, this will return the name or the value for this key. But from this car square braces name, you can just change it. From this you can't change it, but from this you can change this. So car name equals something like, or let me change the model. So the model should be Mustang GT 500. Oops, 500. So if I do this, I will get a modification which I won't be getting from this method, .get method. So now the model name will be modified, and here you can just change it, and let me type print the car's model or print the whole car. So you will see that the model is changed to Mustang GT 500 from just Mustang. Also, if you want to remove an item from this dictionary, what you can do is you can just write del, which stands for delete, then car, and what you want to delete is mileage, because it's too low, I guess. So the mileage is not a string, but now it is. So now this key will be accessed and delete car mileage. So let's run this and print car name and model without this mileage. So this is how you should delete anything or any key value pair in your dictionary. And now let's move to unpacking dictionaries. How to unpack dictionaries like we used to unpack lists, but how can we unpack dictionaries? So to unpack dictionaries, there are basically three ways of unpacking dictionaries. The first one is assigning variables with keys. So what this will do is, we have this car, and what we can do is we can assign variables like we did for lists. Similarly, we can just do for name, model and mileage, that can be A, B and C if I write in sort. So equals CAR, car. So print C. So if I run this, I'm getting MIL, which is the key. So this is what I mean by assigning variables with keys. The variables are assigned with keys. As you can see here, MIL, the mileage, is the key and C is assigned to this key. The second method that we have is assigning variables with the values. So how to do this? For this you just need to write car dot values. So it will just iterate over the whole dictionary and find the values and assign it. So here we have 12. So C will be assigned with 12. So let's run this and see. Yes, we are getting 12. Also, if I want to print B, so let's run this. I'm getting Mustang. Also, if we want to store the whole key value pair in a variable, we also have a method for this. For this, we can use, like we can remove this dot values method and we can just use dot items. Now every key value pair of this dictionary will be stored as a tuple. So B will be this model Mustang. So let's run this and see. Yes, I am getting a tuple of model Mustang. Also, to confirm it, I can just write here type of B, which will show you that it is in the class tuple. So these were the three ways where you can assign variables with keys, with values, and with the whole key value pair, that is in a form of a tuple, which are immutable. Also, the same thing you can do, like you can just remove something and write star b, and it will represent that yes, the first tuple is this, and from after this first one, everything that we have is this b that we use to write others. So its class type is list, and if I remove this and just print b, you will see that here is a list of tuples containing the key value pairs. So this was all about dictionaries, and now let's move for the next topic. So now we are here where everything will get shorter and easier. Using functions. So what are functions? Functions allows you to encapsulate reusable block of code that can be called or executed multiple times. So basically it means that you can create a block of code that performs a specific task for you and can be used multiple times whenever and wherever you want in the program. For example, suppose we have some block of code which is this, some random I'm typing. So this is a block of code and you need to perform this task. All the tasks that's done by this block of code need to be performed many times, suppose 50 times or 100 times, but not simultaneously like loops. You have to perform these tasks on some specific locations. So how can we do this? How can we write reusable codes? For this, you need to use a function. To define a function, you just need to use a keyword def, and then def followed by a function name. So let there be a function name func, followed by these parentheses which will contain the parameters. Parameters are the variable that a function need locally to compute or complete a task. But what does this local reference means? The local variable means that the variable is no longer valid outside its scope. So for example, let there be a variable which is defined under this func, which is x equals 100. So if I want to access this 100 out of this scope, this thing out of this code block, so if I want to just access it, print x, see there is an error which says unresolved reference. If I run it, you will see that name error, x is not defined. So local just means that whatever the variable it is just valid for inside the scope of the function or the scope it is defined for. So x is a local variable for this function, but it is not globally defined. So if I define it globally, for like here x is equal to 0, now it is a global variable, but this x is still a local variable. So what if I run this program? So define func, I have defined this function func, but where to call it? I can just call it here. So now the func function will be called, and this means we want to execute the function that we defined. So this func function basically treats x is equal to 100. So print x, what will be the value of x? It will still be 0 as the global value of x is 0. So if I run this, I am getting 0. But if I run the same thing, this print x from here, it will access the local variable, the local x, and this x is 100. So I will get 100. Then the global variable x is still 0. So what's the meaning of this x if I cannot update it. So what's the use of function? To use a function, we first need to know what is a function, that what is exactly do. What it exactly does is it performs a particular task for you. Like this whole thing is a task for it. So it will perform this whole task for you. And performing a task means it will return you something, like it will give you something back. That yes, this is the thing that you wanted. I have done your task and this is the result. So if I want to do this, I can just use return and return x. So this func will return something and I can store it as x again, like redefining this x, updating its value. So now x will be 100 as x will be 0, and then we will call this function. This function will return 100. It will print 100 and return 100, and this 100 will be updated from this x and we will get 100 back. So see, 100 and 100. So one thing about the function is that it performs a task and returns you something. If I remove this, it will not return you something. However, this can be the consequences, like if you want to print hello world or something like hello. So you can just call it like this, func, and just remove this and see, if I am calling func, it will print hello for me. The more number of times I will just want to print this hello or perform a task, then I will get this hello. And if in case I want to perform anything, any task between these, like world or anything, like here if I want to define x equals 100 and here I want to do x by equal to x divide equals to 10, and after this I just want to print x. So whatever the tasks we want to do, and suppose we need this function, so you can perform any task in between the function calls. I am calling this function that whatever function or whatever thing that I have told you to do, you can do after I do this task. Or whenever I am calling this, it says that perform this task after I have completed this task. Whenever I need you, you have to do this. So let's run this and check. See, getting hello from this, and then world, and then hello, 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 where this, after this first hello or the second hello, this one hello, I am getting x equal to 100, and then after printing one more hello, I am dividing the value of x by 10, and then I am printing again hello, and then I am printing the real value of x, so I am getting it 10.0. So this is how you are supposed to use functions to perform a specific task or any task that you want at any point of your code, whenever you want and whatever you want. But coming back to the parameters, what are parameters? This function, there can be consequences that this function needs a particular value to perform a specific task. So let it be something like it needs a variable a, and it will just change the value of a to a into 10. Like it will multiply it by 10, and then it will just return a. Or we can just write it in sort, like a into 10, and just remove this. So what will this function do? That you have to give a number and it will just multiply it with 10 and it will give you back. So here if I print this, print this function. So this will return, I need to pass a value. So let the value be 3. So I am calling this function. What this will do, it will send 3. So a will be 3 and 3. Here a will be initialized to 3 like this, and 3, it will return 3 into 10. So what it will return is 30, and 30 will be printed, as this function will return 30 and 30 will be printed. So let's see, we are getting 30. If we change the parameter, it will change. If we change it to 7, we are getting 70, or whatever number we want, like 68, 66. So if I pass anything, I will get the value. Also, suppose that we have something that we need two variables. So a comma b, we have two variables, and we just need to multiply these. Let the function name be mul, multiplication, and mul, I want to multiply 7 with 9. So this function will send 7 and 9 as parameters, and 7 and 9 will be multiplied, and then we'll get 7 into 9 back, which is 63. So here we are getting 63. Or even for some complex values, that let the task be a equals a plus 3, and then we have b equals b minus 2, and then we have to return a into b. So if I'm passing 7 and 9, so 7 plus 3 is 10, and 9 minus 2 is 7, so I should get 70. See, you can do all the tasks, like whatever the task is, it will perform the whole task for you. So here, mul of 7 and 9 will give me this 70 back after performing this whole task. So one thing that you should keep in mind is it requires parameters. So while you are calling this function, you need to specify that what is the value. So let me cut this and print a C with this function. What this function returns will be stored in C, and then let me print C. So I will get 70. But one thing that we should keep in mind is we are passing two parameters, as the function needs two parameters. We cannot pass one parameter. Like if I'm passing 7 and I run this, see, missing one requirement, positional argument b. For the value of b, it is not finding what's the value of b. So whatever the number of parameters you will give, it will just start from this position, from the leftmost side, and just fill the values with the value that you provided. Like 7 will be assigned to a. If you should have given any other value, it will provide to b, then to c, then to d, or whatever the number of parameters, it will just move from left to right. But this feature opens the aspect that there can be consequences that a user couldn't give the same number of parameters, or like if there can be something that it wants by default, so which must be written from the rightmost part to make it default. So whatever I am supplying it will be assigned from the leftmost side, and from the rightmost side we can just define default parameters. So default parameters are the parameters which can be assigned to constant values if, while calling the function, does not get required number of positional arguments. So if I am supplying it 7 and I want that if there is nothing supplied for b, you can just set its default value to 10. So if I run this, now mul7 will print 80, as a value will be changed to 7 and then b value will be stored as 10. So 7 will be updated to 10 and b will be updated to b minus 2, that is 10 minus 2, that is 8, and then we'll return 8 into 10 into 8, which is 80. So 80 will be returned and will be stored in C, and then we will print C, that is 80. So this is how you need to initialize these default parameters. But what if I write something like this? I want to set something b equals 10 at this position, at somewhere in the middle. So this is an error, like you can see. Non-default parameters follows default parameter 1. So basically it says that this is a non-default parameter C, and this is followed by this, a default parameter, which is not the correct way to initialize a default parameter. If you want to do this, you just want to have to set this also with a constant variable, like as a default parameter. Then we can use it, C equals C plus 7, and to return A into B into C. So running this, I am getting this 2960. So this is the rule, that if you want to use these default parameters, you have to use these default parameters from the rightmost side, not from the leftmost side or not from the middle. You have to only set the defaults from the rightmost side, from this side, going to the left side. So summing all the up that we studied in this function, we have a function that will perform a specific task for you. It can return something to you if needed. So it will return something to you, or it cannot return something to you if you don't want it to return something. So basically this performs a task for you, and you can call your function whenever and wherever you want, like this. Also, we can set default values for the parameters that we assign or pass. But one more thing that you should keep in mind, like what are the number of parameters that are not default parameters. You must need to pass at least those number of parameters. Like if I have edited this and made this A, B, so at least the number of parameters that you want to provide is A and B. So A and B, 7 and 9. Then if I run this, I am getting 2590, and if I am providing this something like this, so this 30 will be changed to 2, 7 will be assigned to this, 9 will be assigned to this, 2 will be assigned to this. If I am not providing 2, it will be assigned to 30 by default, but as I am assigning 2, it will just assign C with 2, and then whatever I will get is this number 630. So this was all about functions in Python. Now starting with the exception handling. So what are exceptions? There are some things that are not allowed for Python. For example, let me make a function that is for dividing, for getting a quotient for something. So basically it will take two arguments, A and B, and it will return you just A by B. So there's nothing like a problem to us. Like what can be a problem for this? So let me take these inputs dynamically. So let me take a variable x which says int input from the user and say enter number 1, enter num1, and the same thing for variable y which says enter num2. And now as the program will work very correctly, so I just need to print this, like print whatever the function is quotient of a and b. So our a and b will be the number x and y. So this will what the quotient function will return and print. So this is the whole program. So what can be the problem in this? If we see, I'm supplying it like 9 and 3 and it should return 3.0. So the program works correctly. If the program is correctly working, so it will exit with the exit code 0. And anything except this exit code 0 means the program is crashed. So how can a program crash? Suppose if we run it and it's telling us to enter a number and we just provided it as a string with some random numbers or some random string. So if I enter this, it is supposed to get an integer, but it is getting some random string. So it will throw an exception, that is value error. This is an error. So now you can see the program is finished with exit code 1, which means that the program is crashed. So if you are a good programmer, you should protect your program from crashing. So how should you protect it? To protect it, Python provides a try and except block, which says that if we define this whole code, whatever you have wrote, in a try block. So this is a try block. So it says that try this code. However, this code must be indented so that it states that all the code that I have written here belong to this try block. So this block of code belong to try block like this. Now this seems like this whole block of code belongs to this try block. So it just says to try this whole block and accept some exceptions that can be value error, like in our case. So accept this value error, and if I'm getting this value error, I should just print invalid or something like, yes, invalid input. Invalid input. So this means that if the input is invalid, it is not an integer that we are expecting. So it will just write this and the program will not crash. So let's run this and check. Enter num1. It's a real number, anything. And if the number is not a number, like anything, if I run this, it is showing me invalid input. And the program is still working. It has been exited with this exit code 0, not with a random number. Now, as our code is not crashing, we just need to find more of the errors. So what can be more of these errors? So for this case, that for this function that I show you, for this I can just take, as it is dividing two numbers, I can just take the first number anything and the second number be 0. And as you well know, that any number cannot be divided by 0. So if I run this, I am getting 0 division error. So to accept or to handle more of the errors, same thing you need to do. You need to write this except statement and the error that you got, division by 0 error. And for this, I just want to what action that I need to perform is print anything like cannot divide by 0. So if I run this now, I am getting anything like 65 divided by 0. It will handle it. It will not get crashed. It will finish with code 0, that it is working very fine. And now our program handles all the errors. So this is the program where we have the try block, which contains your whole code, and this is the exception handling block, which handles all the errors that we can get, all the errors. It basically covers everything that you can do. Just you have to detect it and write the type of error, followed by what action you actually want to perform if you're getting a particular error. But are these all the errors? Like only two types of error can occur here? It might be possible. But what if you don't know what type of error you will face and you just don't want your program to crash? So for this, let's suppose that we don't know that there is something like zero division error. So we just have to write except followed by these colons and write whatever you want to do if the type of error is not known to you. So print something went wrong. So this should be printed. So for real example, if I type something like division by zero error, what we will see is it will be handled and it will just show us or display us something went wrong, and then the code will not crash and will be finished with code 0. So let's try this. Yes, it's showing us something went wrong that I don't know what went wrong, and then process is finished with exit code 0. So this is how you should use your try and catch block, this except block, which will basically catch the errors and perform any operation that you have wrote here. So basically you can also use this to control the flow of your program. If something has went wrong or any logical error that you got, you can just change the logic too. Like for this case, if we have got something like division by zero error. So what will be this? Division by zero error. Zero division error. So if I am getting this, I may be calling this print just the value of a. So, and also to print cannot divide by 0. Cannot divide by 0. Just display this and print a, whatever the value of a is. Or sorry, it's x that I have made it. So just c cannot divide by 0. And right here answer is this x, that can be written in a formatted string like this. In a formatted string I should write x, answer is x. So if I run this, enter num1, it's anything like 63, and I'm getting division by 0 error. And here the flow of the program is decided. See, 63 by 0 should be 0, but answer is 63. So you can just control the flow of your program using this try and except block. So this was all about your exception handling.